Good morning, Victorious National High School. It's Sunday, September 1. This is the Sci Physics Newscast. Today, we'll talk about electromagnetic waves, the invisible energy all around us. These waves include radio, microwave, infrared, visible light, ultraviolet ray, X-rays, and gamma rays. Though unseen, EM waves makes modern life possible, from Wi-Fi and radio to cell phones and even microwave ovens. They keep us connected and make daily tasks easier. To tell us more, here's the report from our Science Researchers Associates. Let's begin with the basics.
Electromagnetic waves are everywhere around us, and both NASA and WHO highlight how they're vital in technology, communication, and medicine. Radio waves make long-distance communication possible, from radio and TV broadcasting to NASA spacecraft sending signals back to Earth. Microwaves are used in our daily lives for cooking food, but they also power radar systems and satellite communications. Infrared waves detect the heat, helping the night vision devices, thermal cameras, and even weather forecasting. Visible light allows us to see, and scientists use it in telescopes to explore planets and stars. Ultraviolet ray can sterilize equipment and help doctors treat certain skin conditions, though too much can harm our skin. X-rays are a powerful medical tool for looking inside the body, and space agencies use them to study stars in black holes. Finally, gamma rays. The most energetic are applied in cancer treatment and help researchers understand cosmic explosions. According to NASA and the World Health Organization, electromagnetic radiation can be both useful and potentially risky. Depending on the type and intensity, ionizing radiation, which includes ultraviolet rays, X-rays, and gamma rays, carries enough energy to damage living cells. On the other hand, non-ionizing radiation, such as form radio waves, microwaves, cell phones, and Wi-Fi, does not carry enough energy to directly damage DNA. Current evidence suggests they are generally safe at normal exposure levels, but WHO notes that research continues on whether long-term, heavy exposure might have subtle health effects. In short, ionizing radiation poses well-documented risk, while non-ionizing radiation is still being studied, so guidelines encourage safe and limited exposure. Electromagnetic wave technology is often seen as a double-edged sword. On one side, it has transformed society, powering global communication through radio, television, and the internet, driving navigation with GPS, and saving lives through medical imaging and cancer treatments. These advances have made our world more connected, informed, and healthier. But on the other side, there are public concerns and debates. Ionizing radiation, like ultraviolet rays, X-rays, and gamma rays, poses well-documented risk, from skin damage to increased cancer risk, which is why strict safety limits exist in medicine and industry. Meanwhile, non-ionizing radiation, such as from cell phones and Wi-Fi, is generally considered safe at everyday levels, yet ongoing research keeps questions alive about long-term exposure. In short, EM waves were central to modern life, but society continues to weigh the enormous benefit against the potential risk, reminding us that with every technological leap comes the responsibility to use it wisely.
Looking ahead, both World Health Organization and NASA see tremendous potential in the future of electromagnetic technology for medicine. NASA is already exploring innovative applications using electromagnetic fields for non-invasive health monitoring, and even advancing imaging techniques that could give us clearer scans without the risk of harmful radiation. At the same time, the World Health Organization stresses the need for continued research into the long-term effect of low-level exposure from everyday devices like smartphones and Wi-Fi routers, while WHO reports no confirmed health risk from typical exposure. Both WHO and NASA agree that more investigation is needed into possible non-thermal effects, such as links to childhood leukemia or neurological condition. In conclusion, electromagnetic waves shape nearly every part of our lives, from communication and medicine to even space exploration. But with their power come risk. Ionizing radiation is also known to damage living cells, while non-ionizing radiation remains under scientific study. That's why informed use, strong safety measures, and ongoing research are essential. As technology moves forward, the challenges is not only to harness electromagnetic waves, but to ensure we use them wisely, for today and for the generations to come. That's all for the news we have for you today. Once again, we are the Sci Physics Newscast. Goodbye.